Fundamentals of probability. We are going to discuss some basic probability rules here. Objectives are compute probability theoretically and empirical, which is experimental probability computation. So probability means chance. If you are sure or 100% certain about an event, then the probability of happening that event is 100% or 1. Either you write 100% or 1 in, normally we write something in between 0 and 1 for the probability. Okay, 0 means the chances of happening that event is impossible, 0. Like for example, what is the probability of finding 8 different days in a week? Because there are only 7 days, the chance is impossible. That's why probability is 0. And what is probability if you randomly pick a day from 7 7 different days? What is the chances of getting Monday? The chance is 1 out of 7, because there is one Monday out of 7 different days. So it's in between maybe 0 to half, which is possible but not that great. If something is half and half, for example, if you flip a coin, what is the probability of getting head or tail? So let's say there are two sides of a coin, head and then tail. If you flip a coin, then chances of getting head or tail is 50-50. That's a 50% chance. If the chance is more than 50%, let's say you have 1, 2, and 3 numbers in a bucket, and if we pick one number randomly from this bucket, what's my chance of getting odd number? There are 2 odd numbers and 1 even number, so my chances of getting odd number is higher than 50%. It's likely. Okay, let's say there is another situation. There are this number 1, 3, 5. If I pick a number randomly from this bucket, what's my chance of getting an odd number? All these numbers are odd, so my chance is certain, 100%. So always keep in mind, whenever you try to compute probability for an event, the answer is supposed to be in between 0 to 1. Okay, it cannot be more than 1. It cannot be less than 0. So there are 2 different types of probability we are going to discuss. Theoretical, without doing any work, if you try to find the probability. Let's say, think about if we flip a coin, two-sided coin, head and tail, what's the chances of getting head if I flip a coin? The chance is half. That chance is my theoretical calculation, coming from theoretical calculation. When you do the experiment, that chance may be greater than half or less than half based on how many times you do the experiment. But theoretical means, theoretically, head's supposed to be there for half of the time. Okay, and when we flip a coin, that process is called experiment. And when you flip a coin, either you will get head or tail. Those possible outcomes form a space that's called sample space. So what is a sample space? In this particular example, it would be head and tail, both outcomes, all the outcomes. So all possible outcomes, they create sample space. Experiment means this process of doing this, flipping a coin, is experiment. Event, E means getting head is one event, getting tail is another event. So event is subset of this sample space. So head itself or tail itself, they are subset of this one. And if you try to add all the theoretical possibility of these outcomes, then the total outcome is supposed to be 1. What is the theoretical probability of getting head? Half. What is the theoretical probability of getting tail? It's also half. If you add them, it's supposed to be 1. So that's the sum of the theoretical probability of all possible outcomes supposed to be 1. When we calculate theoretical probability can be calculated by using this formula. Number of outcomes in event E divided by total number of possible outcomes. Let's go to the same example. The sample space for this flipping a coin with one side head and another side tail. There are 2 possibility, head and tail. And we would like to find out what is the probability of finding head. That event is finding head. So how many outcomes are there in this sample space? Head, there is 1 outcome. And how many total outcomes? There are 2 outcomes, total outcome. That's why it's a half. So number of event happening head is 1. And number of total events in sample space is 2. That's why it's a half. That's how we calculate theoretical probability. But if you have to find the empirical probability, which is experimental probability, you need to find out, you need to do the experiment and you need to calculate total number of outcomes divided by total number of observed occurrence. For example, let's say I flip a coin with the 2 outcomes, head and tail, 10 times. And these are the outcome I got. Head, tail, head, tail, head. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the total outcomes. So how many outcomes I do have in my experiment? 10. And I would like to find out what is the probability of getting head from this experiment. So I need to count how many heads are there. 1, 2, 3, 4, 5, 6. 6 out of 10. That's the probability I can observe from this experiment. Let's do some problems from here. First couple of questions are just understanding. For example, let's say number 3, probability that is based on situation in which we observe how frequently an event occurs is called. It's a based on situation in which we observe. Observation means it's experimental. That's why it's empirical. Fantastic. So first couple of questions are like that. So let's just start with question number 8. This is the actual numerical problem. A 12-sided die is rolled. Let me just Google 12-sided die. Okay, so this is what the 12-sided die look like. Image, yeah, this one. There are 12 sides, and then when you roll it, the chances of getting one side is equal to another side. So a 12-sided die is rolled. The set of equally likely outcome is, these are the equally likely outcome. It could be 1 through 12. Find the probability of rolling a 12. 12, look at here. How many 12s are there? Just 1. 1 out of how many outcome? 12 outcomes. So that's the reason the answer is 1 out of 12. And I got that using this formula. Number of outcomes in an event E, which is 1. And total number of possible outcomes, 12. That's why it's a 1 out of 12. Let me choose this question. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt an ace. So first of all, if you don't know about the cards, there are 52 cards. There are 4 different colors, 4 different suites, hearts, clubs, diamonds, spades, and these are the type of the cards. And there are 4 aces, of different colors out of 52 cards. So we are trying to find out, if you draw 1 card randomly, then what is the probability of getting ace? There are 4 aces out of 52. So the answer is 4 out of 52. But you have to simplify that. Simplify that expression. So I'm going to just use, so it's a 4 out of 52. 4 ace out of 52 cards. So the probability is 4 out of 52. If I write down that answer here, 4 out of 52, it says, hey, although your answer is right, but it's not in right format. So you have to read the instruction, type an integer or simplified fraction. If you simplify this, it would be 1 out of 13, because 4 is the common factor between 4 and 52. Make sense? A fair coin is tossed 2 times in succession. So there is a coin. So the possible outcome for the coin is head or tail. So there are 2, first time and then second time. You flip a coin, you toss a coin 2 times. So there are different possibilities. You could have head first time, head second time. You could have head first time, tail second time. You could have tail first time, head second time, tail first time, and tail second time. So you have this possibility. So when you toss a coin, you might have head or head, head and tail, tail or head, tail and tail. Now from this is your sample space. Find the probability of getting exactly 0 tails. So you're going to see how many of them don't have tail. So for the first one, there is no tail. So exactly 0 tail means only 1 out of 4. So the answer is 1 out of 4. Okay, a single die is rolled twice. So you have a die with the 6 face, 1 through 6, and then you are rolling that dice, twice. When you do that, let me just copy this outcome. This is the outcome from the first roll, and these are the outcome from the second roll. So it could be 1 and 1, 1 and 2, 1 and 3, 1 and 4. So there are, if you count all of them, there are 36 possibility, because 6 possibility from first, when you roll a die first time, and then another 6 possibility from the second time. So it's a 6 times 6. If you remember, it's from fundamental principle, counting principle. 6 times 6 different outcome from the first roll, and then 6 different outcome from the second roll. So 6 times 6, 36. So the question is, out of this 36, find the probability of getting a first number that is less than the second number. So the first number is supposed to be less than the second number. So look at here. You have to count it. This is equal. First number is less than second number. So all these numbers are less than second number. 1, 2, 3, 4, 5. So you are going to calculate, if you look at here, 2 is greater than 1, so you don't include that. 2 is equal to 2, you don't include that. So what you can do is, you can just draw a diagonal from here. You can draw a diagonal from here, and then you can count everything on the right side of the diagonal. So if you just focus here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 different possibilities. As I go to the next row, my counting number will decrease, because the first option would be greater or equal to the second one. So for the first row, if you notice here, both of them are equal, so we don't include them in our counting. But the first is less than second, first is less than second, first is less than second, so we count all five of them. So it's actually 5, and then after that 4, 9 plus 3 is 12, plus 2 is 14, plus 1 is 15. 15 out of 36. So 15 out of 36. In 15 cases, the first number is less than the second number out of 36 different possibilities. So you have to just simplify that. 3 times 5, 3 times 1, 3 times 2. So it's a 5 out of 12 probability. So the answer is the probability of getting a first number that is less than the second number is 5 out of 12. Okay, this is the data for educational attainment of a country's population age 25 and over, of less than 4 years high school, 11 male, 12 female, 4-year high school only, 26 male, 29 female, and these are the total numbers. Some college less than 4 years, 17, 26. And based on this data, we need to find the probability that a randomly selected citizen age 25 or over had some college less than 4 years is some college less than 4 years. So what is the number? That's some college less than 4 years is 43 out of 164. 164 is total. So the answer is 43 out of 164. If you try to simplify that, 43 out of 164, because there are 43 of them who have some college but less than 4 years out of total 164. If you can simplify, can you simplify this? No, 43 is a prime, so 43 out of 164 is the answer. So you can see that I found how many of them have some college less than 4 years, which is total 43, and then out of total population, which is 164. Okay, so that's all for this section.